Welcome to the Department of Applied Mathematics and Statistics online open house. We're delighted to have this opportunity to share information about our program and about Johns Hopkins generally with potential applicants to our program. The presenters here, I'm Dan Naiman. I'm a professor and director of graduate studies and director of the Financial Mathematics Master's Program, and I'm interested in statistics, probability, and computational statistics. And I'm here with Laurent Younis, who's professor and department chair. He's interested in statistical properties of Markov random fields, image analysis, deformation analysis, and shape recognition. And in addition to ourselves, we have a couple of people in here as well. Sanjala Williams, who is our graduate professional career advisor. She's a recent addition to our program, and she's going to be talking later on about how various people like her help students in the program address career planning and basically get them ready for interviewing and for embarking on their careers while they're in the program. And in addition, we have Kristen Bechtel, who is our academic program administrator. She's here, Sanjala's here, and other staff are here to answer questions. So, welcome. Our aim is to provide you with information that should help you decide whether you want to come to Johns Hopkins and whether it's a good fit for you. We're going to try to touch on what it's like to be a graduate student here, what our research and academic programs are like, who the faculty are, what their interests are, who would be mentoring you in the program, unique opportunities that are available to you here at Johns Hopkins, and what recent graduates of our program are doing today. By the way, there's a photograph here of one of the quadrangles on the Hopkins campus, and we'll be showing you some images of Johns Hopkins. I believe it's one of the most beautiful universities in the world, and certainly, as far as I'm concerned, it's the most beautiful urban university in the United States. Johns Hopkins has a long history of being a leader in research for 37 years. This university has led U.S. higher education in research and development, spending a record of $2.3 billion in fiscal 2015. And you can see a ranking here. We're far ahead of other universities in terms of our research and development expenditures. And this has a huge influence on the environment here at Johns Hopkins, where research is primary. The university has 9 divisions, including the Whiting School of Engineering, which is the school that houses our department. In addition, we have something called the Applied Physics Laboratory, the Johns Hopkins School of Medicine, the Bloomberg School of Public Health, and the Krieger School of Arts and Sciences. And there are other divisions, 4 more divisions that I won't mention here, but to a great extent, faculty in our program interact with faculty in these other programs quite frequently. The School of Engineering has 9 PhD programs, 14 master's programs, 21 part-time master's programs, and 16 online graduate programs. We have lots of students, 1,600 graduate students, 1,800 undergrads, and 2,500 part-time graduate students. The faculty in the School of Engineering consists of 181 academic and 31 research faculty, 32 teaching faculty, and 43 associated research scientists and engineers. And faculty in our department come from these areas. We have academic faculty, we have research faculty, we have teaching faculty, and we have research scientists as well. Just to give you an overview of the department, we have 27 faculty members, roughly 41 PhD students, 116 master's students, of whom 65 are in the AMS, that's the Applied Mathematics and Statistics Master's Program, and 51 of them are in the Financial Math Master's Program. And we have 285 undergraduate majors. We're one of the most popular majors on campus because what we do touches on so many areas that students are interested in. Our faculty have lots of collaborations. We collaborate with faculty in biomedical engineering, biostatistics, psychology and brain sciences, mechanical engineering, electrical and computer engineering, computer science, oncology, physics and astronomy, earth and planetary science, sociology, cardiology, and we could name many more areas or departments that faculty in the program interact with. There's a strong interest in Johns Hopkins in interdisciplinary collaboration, and we play a huge role in collaborating with other programs and other departments and other research efforts. We offer 3 graduate degrees: the Master's in Applied Mathematics and Statistics, which can either be an MA or an MSc in Financial Mathematics, and a PhD in Applied Mathematics and Statistics. So I'm going to go over the 3 programs and just give you a brief idea of what typically happens when you are a student in those programs. In the MSc in Applied Mathematics and Statistics, the requirements, which are typically completed in 3 semesters, are to complete 10 graduate level courses or 8 graduate level courses plus a thesis. So some students get involved in a research project while they are graduate students, and they, instead of doing 2 of their courses toward the 10, they can do a thesis instead. 3 of those 10 courses should be in a focus area, for example, statistics or probability or optimization. 3 courses can be in other departments. So we have many students that come to our program, they want to take courses in mathematics. So we have a math department, they take courses there. They take computer science courses, they take biostatistics courses, they take courses in biomedical engineering, they take courses in economics. There are plenty of other departments which where students might find interesting courses that they want to take and use toward their program. And we have a computing requirement. So we expect all of our students to show some facility in computing while they're in our program. And that requirement is usually met by taking a course that is heavily computer intensive. The tracks or the focus areas that a student can focus on while they're in the program, these are the focus areas: probability theory, statistical learning, operations research or optimization, computational and applied mathematics or scientific computing, and discrete mathematics. I should mention that the program is quite flexible. Once you've completed the 3 courses in a focus area, those other 7 courses you would take, you pretty much are in a position where you can design your own program, and students find that to be a very attractive feature of our program. Okay, so we also have an MSc in Financial Mathematics. The requirements for this program which are again typically completed in 3 semesters, although some students stay on for an extra semester because they like being in our program and want to stay longer. So typically a student's required to take 12 courses, and we have various tracks. You can focus on a particular area of financial mathematics, or you can do what we call our legacy track, where we basically spell out what courses you would take, up to 9 courses that would be required in 3 electives. But now students recently began a program where students could create a focus track, and it's introduced a lot of flexibility into our program. And now at this point, if you do the focus track, you have 5 required courses and then 7 electives. And the only requirement is that those electives have to be somehow a coherent program in financial mathematics. This program also has a summer internship requirement. We have a summer orientation that happens right before the semester begins. And I should have mentioned this about the MSc in Applied Mathematics, that summer orientation is available both to the MSc in Financial Mathematics students and the MSc in Applied Mathematics students. And we also have a winter intersession program, which also is available to the Applied Mathematics students. In this winter intersession program, we'll be focusing on computing with applications in natural language processing. So we've listed here the tracks or focus areas. You can focus in risk management, asset management, derivatives, quantitative or high frequency or algorithmic trading, fixed income, and commodities. And I should say you can also create your own focus area. Okay, and then there's the PhD program. So our PhD program has a coursework requirement of 12 one-semester courses. We have something called the introductory exam, in which students have to demonstrate capability in linear algebra, probability, and real analysis. Once they get past that exam, they would be preparing for something called the PhD candidacy exam. So essentially what's happening at that stage, once you've passed this introductory exam, is that you are developing a deep appreciation for some field of applied mathematics, and also developing broad understanding of that field, and preparing for this oral exam where faculty will be asking you questions both about some specific topic that you have chosen, but also about the broad area that that topic resides in. After that, there's something called the Graduate Board Oral Exam. This is an exam that every PhD student at Johns Hopkins here at the Homewood Campus must take this Graduate Board Oral Exam. It's an exam that's administered by faculty, a faculty committee, both of faculty inside the department as well as faculty outside the department, usually having some interest in the area that your work is in, that your proposed work is in. And then, of course, the expectation is that you will write a PhD dissertation and finish off with a thesis defense. The department faculty essentially focus on disciplines that are listed here on this page. So we have faculty that are interested in statistics and statistical learning, probability theory, discrete mathematics, financial mathematics, optimization and operations research, and computational mathematics. And it's probably a good idea to view this rather than view this as a bunch of sets that are disjoint. These actually overlap. So imagine this Venn diagram with all these overlapping sets. Folks that work in the department in one of these areas will typically be involved in research that touches on all of the areas, or at least a large number of these areas. So faculty are not completely focused in one particular area of applied mathematics, but most of the faculty are quite broad in their interests. And our interests are often driven by applications. So we have faculty that work in the area of social networks, computer vision, healthcare, computer science, finance, urbanism, astronomy, physics, computational medicine, computational biology, and computational anatomy, and many other fields. So the faculty, we're always, as applied mathematicians, looking for areas where research is carried out in which mathematics is applied, and researchers all across the university are, in fact, all across the world, are looking for faculty in applied mathematics to collaborate with. And so we develop these collaborations, we encourage our students to be involved in collaborations, and it leads to a very dynamic research atmosphere in the department. Lots of people doing lots of different things. In terms of outcomes, our master's graduate students are typically, after they graduate, ending up in either a career in industry or in government or going on to some PhD program. So many of our students are preparing for jobs in finance or in consulting and get involved in various work as graduate students that prepares them for these careers. Students go on and get jobs in regulatory agencies. Again, many of them go on to PhD programs. So we've had recent students, this is a list of some of the universities that some of our recent PhD students have applied to and landed in and are currently enrolled in. The outcomes for our financial math masters are somewhat similar. We have a large number of students that go out into industry, and you can see a listing here of many of the companies that our students are working in. Not all of those companies are listed here, but this gives you a representative list of companies that have hired our students recently. And of course, many of our students go on to PhD programs. So students go on to PhD programs in our own departments. Often students, when they get to our program as a master's students, ask us, is it possible to apply to our PhD program? And we certainly encourage our master's students to apply to our program. And in many instances, students are admitted to our PhD program. Some of our master's students have gone on to PhD programs in other departments at the university, but they go to PhD programs at other places in the country as well. We've even had a student in the financial math master's program that went on to law school. So there are lots of possible outcomes for a master's student in our program. And the situation for our PhD grads, again, is somewhat similar. It's roughly a third of them go on into industry, a third of them find some government job, maybe working at the Department of Defense or some other government agency. And many of them have gone on to get academic positions. So listed here is some of the universities where our students have landed in academic positions. I'm going to, so I mentioned earlier, I introduced Sanjala Williams. Sanjala is a recent addition to our program who is trying to help students prepare for their careers. And I'm going to turn over the microphone to her so she can tell you a little bit about what she does and what the resources are here at the university for helping a student with career development. Sanjala?
Hi. So I am a new addition to really help students and support the students in their future endeavors to work in industry related to financial math or applied math and statistics. And I kind of feel like I have a dual role with working with students. One is doing some individual appointments. So I work individually with students one-on-one. I also do workshops. Another side of what I do is try to do some employer development to also develop more relationships, more connections for students to go into industry. It's very important that students feel like they have the ability to have a good outcome, which is landing a good position. So whether that's here in the United States or back in a home country, we want to really support students through that process. And so through that, I do a lot of things with students. Everything from career development. So even though you might have already decided to come to a grad school and you think that that's a concrete step, some students still aren't sure how they want to realize their degree. You saw that now there's a lot more flexibility in both programs. And so there's a lot of choices that you still can make. So that career exploration piece is still important. And so I will work individually with students to help them figure out what path they want to take. I also do things to help students develop their tools to be professional. So developing their resumes, developing customized cover letters. I also help students with job and internship strategies. So that's something that's very important. A lot of times students don't understand how to do a job search. What steps should I be taking? How do I timeline? How do I do all those things? And so I'm very concretely helping students through that job and internship search process so that they're on track. I also help with interview preparation. So I do everything from teaching students techniques and skills with interviews to actually helping them practice by doing mock interview situations. We also have a thing called Interview Stream where you can do video interviews and you can actually send those to get reviewed by anyone. So it's a very nice tool. Also, I advise students on networking strategies. Networking, as we've learned through many student stories, is the number one way that our students are getting their opportunities. And so knowing how to network is vital. And so I need to teach those strategies, and that's what I do. I teach it. I actually try to model it, and I also try to help connect students to professionals using LinkedIn, our online alumni network, and many other tools. So you'll have access to Johns Hopkins Alumni Network to go forward if you choose our program. And then also I help them with job fair preparation. There's several job fairs that you will be able to attend. Not only JHU job fairs, there's a next job fair for STEM that's new, that was new this year. There's a general job fair that you're able to go to. And you also will be invited to the School of Business job fair. So I am very active in preparing students to capitalize on those job fairs where you have an opportunity to meet with an employer face-to-face instead of just sending an email to them, and how to capitalize on that opportunity. And so that's really my goal, is to work with you to ensure your success in realizing how you're going to translate what you're learning in the classroom to the real world.
Thank you, Sanjala. I should mention that whenever I walk by Sanjala's office, there's always a graduate student in there, and she spends lots and lots of time with our students, and she does a great job at it, at helping them. I wanted to review our application requirements. We have an online application. That application should include a statement of purpose. There's a supplementary information section where you can provide extra information about yourself that you might want us to see. For example, if you have a paper that you've written that you want to share with us, some sample of your work, that's the kind of thing that you could put in that supplementary information section. And there's a non-refundable fee of $75. We require 3 letters of recommendation. We expect to see unofficial transcripts from each undergraduate and graduate institution that an applicant has attended. We require GRE scores. The general test scores are required. The GRE advanced test in mathematics is recommended but not required. And if you are an international applicant, we want to see your TOEFL or IELTS scores. So more information about how to apply and some self-evaluation guidelines are on our website and can be found at this link. The deadline for applying is January 15th of 2018. I should mention that in addition to this link, there's lots of information on our website about our graduate programs and about what our faculty do, what our students do. You can take a look at research that's been done, dissertations, what the areas that students have worked on in their research. So it's all there. There's lots of stuff online about us.
Let me add one thing on this. I believe that also when you apply, you have the opportunity to apply for financial aid, which goes through the financial office of the university. There is very little financial aid available from the university for master students, but when we see that, we take this into account and we may be able to help you by waiving part of the tuition if we see that it would be helpful for you. So don't hesitate to use this option also when you apply.
Here's some data on our admissions from last fall, or for last fall, I should say. So we had 774 applicants to the Financial Math Masters. Of those, 169 were offered admission. We had 475 applicants to our Applied Mathematics and Statistics Masters, and of those, 148 were admitted. And 153 PhD applicants and 30 were offered admission. Baltimore is a great city. I've lived here since 1982. It's absolutely just a wonderful place to live. It has a fantastic downtown waterfront. Shown here in this photograph, it really does look like this. And we're only 1 hour from Washington, D.C. and 2.5 hours from New York. We're known for our outstanding crabs, although we have lots of great restaurants, and crabs is not the only thing you can get here in Baltimore. But that's certainly something that is the quintessential Baltimore dining experience. The Homewood Campus, as I mentioned earlier, is a beautiful campus. It's in the northern part of Baltimore City. It's very green. It has lots of open space. And as I said earlier, I consider this to be one of the, if not the most beautiful, at least one of the most beautiful urban universities in the world. Here are some photographs taken of areas around campus. North of the campus, north of the campus, there are a lot of apartment buildings where our graduate students often live in these apartments. I guess that's the most common place for students to live, is either north or east of the university. South of campus, we are just south of us, literally 100 yards away from our department building, is the Baltimore Museum of Art, shown here, and the adjoining sculpture garden in the lower left corner of the screen. There's a huge number of restaurants in the neighborhood. South of campus, there's a new restaurant called Our House, where chefs come in and try out a lot of chefs who are just starting out and given an opportunity to feed lots of people their new cuisines. And so students and faculty and staff at the university are often seen eating there. East of campus, we have a neighborhood called Charles Village. Charles Village is filled with restaurants. There are all sorts of choices for the kind of food you can eat. Again, there's some tall apartment buildings in the area where students live, and we also have row houses that are in the neighborhood that students live in. West of campus, there's a neighborhood called Camden, which was rated recently as the #8 hottest neighborhood in the United States. We have the Druid Park, which is a beautiful park, and the Baltimore Zoo. It's only 3 minutes away. And again, Camden has lots of restaurants and shops, and it's a great place for hanging out, a great place to go get a cup of coffee or a quick meal. It's a very fun part of town. Our graduate students have several opportunities to form groups and meet in these groups with common interests. So we have something called the Graduate Representative Organization, the National Society of Black Engineers, the Society of Hispanic Professional Engineers, Society of Women Engineers, something called Women of Whiting, and numerous special student interest groups. So for example, students who are interested in algorithmic trading might start a club that is focused on algorithmic trading. Or we have students that form groups that are interested in some sort of maybe eating in restaurants on a regular basis. So there's all sorts of clubs, all sorts of groups of students doing interesting things. And the experience for students, I think, is a very broad one. Pretty much anything you happen to be interested in. If you're interested in music, if you're interested in athletics, maybe you like playing ping pong or badminton, students get together and do these things. There's lots of facilities on campus for students to make use of for practicing music, doing sports, just everything you might imagine would happen on a college campus. We're going to wrap things up. Feel free to contact us by sending an email to either Kristen or Pam, and we will try to address your questions. I want to thank you on behalf of all of us for participating in this online open house today, and hope that it's been helpful to you. So, and we look forward to hearing from you, and we hope you apply to our program.